Lesson 14.1, Part C. Now I rushed through that real quick because I was closing in on 10 minutes. So I want to finish up real quick here and explaining how we got 3 pi. Now here B is 1/3. It is tangent. The period for tangent is pi. So we will divide it by B, which is 1/3, which is the same as multiplying by the reciprocal, and we get 3 pi. Alright, let's take a look at a very crazy looking graph, but it is sinusoidal. There's a wave, there's a rhythm to it, and a pattern to it. And we're going to find amplitude, period, frequency, and the equation of the midline. Now before we do this, I want to go back real quickly to earlier questions and state something that we didn't state before. Here, 3 represents the amplitude. Here, the amplitude is 0.5. Okay, we hadn't done that before. I wanted to make sure that was clear that that is amplitude. Alright, now we have this table that tells us some things right here. We also have these pieces. Now, we're going to use those to do this question. The amplitude, it says on the previous page, can be found by doing this also. The maximum minus the min divided by 2. The maximum height achieved, which in this case is 8, minus the minimum value achieved, which is -4, and divide by 2. You get 12/2, which gives you an amplitude of 6. Now, to have an amplitude, it goes so many units above the midline and so many units below the midline. We need to find the midline next. Midline on the previous page says down here, oh, they don't have the midline. I thought I saw it there and I can't remember. Well, okay, then I'm going to teach you. The midline is the maximum number achieved, so 8, the highest level, plus the lowest level, divided by 2. So we're finding the average of these two numbers now. That gives us 4 divided by 2, so 2. Now 2 is a horizontal line. Excuse me. So at 2, we're going to put a line that represents the midline. In other words, that goes right through the center. Now, is that the center or not? Let's find out. From the center, if I go with an amplitude of 6, I go from 2 to 6, I add 6 and I get 8. If I'm at the center and I take away 6, I get -4. So that is right in the middle. So that is the midline. We've taken care of the midline. We've taken care of the amplitude. Now we need period. Well, if we start here, how long does it take for it to repeat this pattern? We go up and down and up and down. This looks like it completes a cycle, but then it goes up, so it's still unique. Comes back down, and we get to here. Now from that point on, the pattern will repeat. So what is that length? Now, this is just on a number line, so we would say the period is equal to 6.2, 6.3, and that works. Now we have not talked about frequency, but the relationship between period and frequency is that they are reciprocals. You can complete one cycle in 6.3 units. Again, you could do the division, get a decimal for it, that's fine too. So you could write 1/6.3 or even 0.159. Both are good. And that's all from the picture. Now, how do we graph these functions? All right, well, let's think of for reference sake, let's think of the regular sine. Sine has a high of 1, a minimum of -1. It's supposed to have a period of 2 pi. Well, in front of sine, there's no numbers, which means the amplitude is equal to 1 still. It has not changed, so it's the same. However, this affects period. So the period will be, and let's do radians. So 2 pi is the period for the regular sine function. We're going to divide by b. Well, that's the same as multiplying by 3, so 2 pi times 3 is 6 pi. So to make this fit, I'm going to say this is 6 pi. Now again, sine goes up and down and back up in 2 pi. Halfway through, it's at 0, and it starts at 0. So halfway through this one would be 3 pi, and we would then just draw our graph. It would be here to start with, here halfway through, and here at the end. Halfway through that would be a high of 1, halfway through here would be a low of -1. Now it doesn't look like it changed much, but regular sine repeats itself within 2 pi, so it probably looks something like this. 2 pi. The second one, notice nothing in front of theta, so our period stays the same. Okay, this one is A, so that's amplitude. So amplitude is affected. It doesn't go as high, so our amplitude is equal to 1/3. So if this is our normal one, oops, sorry, +1 here, then now it's only going to go 1/3 as high. But the period is the same. So it's going to go, it's going to be squished vertically. Cosine. Now cosine starts high, comes back down, and goes back up. This one is amplitude, so it's going to go as high as 2 and as low as -2. The period is affected. 2 pi divided by 1/4 means we're going to have 8 pi. So I'm going to make this 8 pi. Halfway through is 4 pi. So we're going to start high. We're going to end high. Halfway through will be at its low point. And it's going to, halfway through that, it's going to be going through 0. So here we have a curve. Oops, sorry. It looks like that. Higher than normal, and the period is longer than normal. Next one, we have amplitude equal to 3, and our period is 2 pi again, divided by b, which is 2. That makes our new period pi. So here's pi, here's 2 pi, what it should be, and now it's going to finish there. The amplitude is 3, so it's going to go higher than before. And again, it's going to start high, and after pi, it's going to be right back where it was. Halfway through, at pi over 2, it'll be at its minimum. And here is the new cosine graph with a shorter period and a bigger amplitude. This finishes lesson 14.1.